I truly appreciate nature. I enjoy the sounds of the forest and streams, and the deep, rich colors of the moss and soil. Often I find myself stopping to take it all in. I am convinced that nothing we make compares to what was already here.
I'm also curious about my world. I want to know how it came to be, why it is the way it is, and how it will be long after I or anyone I know are gone. Loving nature and being curious about my world are two things that link me to people all over the world, past and present. On this episode of This Is Everything, we are going to look to the originators of philosophy, to some of the first people who questioned the nature of reality itself.
If you really wanted to get to know the world around you, a good starting point might just be asking, what is everything made of? You may be familiar with the periodic table of elements, which organizes all of the known elements by group, and everything in existence is made up of a combination of at least one of these elements.
The water in the river is made up of hydrogen and oxygen atoms. The rocks around me are mostly silicon and oxygen. The air we breathe is nitrogen, oxygen, and argon. Organic matter like me and you and the trees contain a lot of carbon. Everything here has a distinct atomic recipe. We take that information for granted nowadays, but those who lived thousands of years ago had to come up with their own answers for what the world is made of. And some of them got pretty close to the truth. We begin in the 5th century BCE in Greece, when a man named Democritus and his teacher Leucippus developed the world's first known atomic theory. They were the first in a line of atomists who believed that the world was composed of tiny, imperceptible, and indivisible atoms. In fact, the word atom is derived from the Greek word atomus, which means uncuttable or indivisible. The key takeaway is that there is a limit to how small things can get.
The atomists looked at the world around them and determined that the way everything behaves and exists wouldn't make sense without the existence of atoms.
To help us understand this atomist theory, it might be helpful to consider what it would mean for the opposite to be true.
What if we could divide things up forever? And what if there were infinities within each infinity? How would the world look then? Another Greek philosopher, Zeno of Elea, made an argument for this exact reality. It is illustrated in one of his thought experiments about a race between a warrior and a tortoise, represented by toys I borrowed from my nieces.
The van and the Triceratops are locked in a race, but the Triceratops has a sizable head start. The van catches up to where the Triceratops is, but in that time, the Triceratops has already advanced a little bit further, even at its slow pace. By the time the van catches up to the next location, the Triceratops has already gone a little bit further. The van again catches up. The Triceratops is gone. And this happens forever. The van never catches up to the Triceratops. Now, this may have frustrated you already, because of course the van is going to overtake the slower Triceratops.
But in Zeno's weird world, the van never catches up. There's always going to be a gap between the two. It gets smaller and smaller forever, but it never closes. This is some of the weirdness that occurs when we don't put a lower limit on the size of things.
So let's make this discussion of infinity a little bit more tangible. And right now, I have this popular candy bar, and I'm going to break off a piece. Now I have half of the candy bar remaining. I'm going to break off another piece. Now I have a quarter remaining. And then again, I break it off. Now I have an eighth of the original size of the candy bar remaining. And then I break it in half again. Now I have roughly a 16th and a 32nd. Now, if I keep cutting this piece in half, I can get down to a 64th, 128th, 256th, so on and so forth. The question though is, can I keep cutting this piece of candy down forever? So we just considered this question in the context of a race. It was the space between the two racers that was being divided forever, and the ever shortening gap would never close. But that was space. Now we're talking about dividing matter forever. Now, with the candy bar, I could argue that infinite divisions are not possible simply because I can't imagine how something with a clear beginning and end can have an infinite amount of anything inside. If the candy bar has an infinite amount of matter, then so does the plate, and the picnic blanket, and each of the billions of grains of sand on the beach. It makes more sense, admittedly with hindsight, that inside of a finite thing, there would be a finite number of things, even if that number of small things is incomprehensibly large. Another big leap the atomists made way back then was to propose that there were only a select number of atom types. They saw enough commonality among the things around them to say that there were only four elements: earth, water, air, and fire. Everything in existence was made up of some combination of these four elements. And even though four elements is far fewer than the 92 elements that occur naturally on Earth, it is still a remarkable breakthrough made millennia ago. So, what is everything made of? We've got an answer for that. It's atoms. But then, where does everything exist? The void. Nothing and nowhere in particular. An infinite, dark, and three-dimensional canvas where everything we know exists, where atoms come together and form the visible world. That the philosophers of old could predict and justify the existence of a great nothingness that underpins our visible reality is pretty thrilling to me. They couldn't see it, nor could they prove it, but they said it was everywhere, in everything and around everything, and that flies in the face of our senses. It feels counterintuitive until you hear their arguments. Lucretius was a Roman poet and philosopher, and he was probably the biggest champion of the Greek atomists. He wrote an epic poem titled On the Nature of Things that summarized atomist arguments. He has this to say on the void: empty space exists, untouched and void. If it did not, motion would cease to be. For that which is the function of matter, to impede and block, would operate at all times in everything. His poem is not what I would call romantic, but it is straight to the point. If there were no void, and there were no empty space, then motion would cease to exist. Everything would be in everything's path, and thus everything would block everything. In fact, I couldn't move from this spot. Now let's talk about why we need the void for motion. To do so, we'll use another one of Zeno's paradoxes. This one involves a solo traveler. If you wanted to get from one point in space to another, you'd have to pass through a point that's halfway between the beginning of your journey and the end. But to get to the end from this halfway point, there is another halfway point you have to cross. And from that halfway point, there's another one, and then another one. No matter how close you get to the end, you've still got another halfway point to cross. There is an infinite number of them, so it takes us forever, and we never actually reach the end. But let's take it back and think about the implications of this. If this infinite sequence of halfway points keeps us from reaching the end, then it will also keep us from reaching the first halfway point, or the quarter point. In fact, any distance would take an infinite amount of time to traverse, because there would be an infinite number of points we'd need to cross.
This is the version of reality Lucretius argues against, one where everything is blocking everything, and there's always something in the way of any motion. The things blocking the path of the traveler are in turn blocked, and that is because there is no void or space where things can be displaced into. We can use another example to illustrate this.
Now let's look at this small bin full of ping pong balls. And think of this as a miniature ball pit. Now, each of these ping pong balls is sturdy, they don't bend easily, they're solid.
When I stick my hand in the bin, the ping pong balls give way like the balls in a ball pit. That's because there is wiggle room. There is somewhere for the ping pong balls to go when they are displaced. The ping pong balls can move over and around each other, and even though the bin is filled, there are gaps because of their round shape. Think of these gaps as the void the atomists conceived of. The void is that wiggle room. The argument goes that because motion exists, then this void has to exist.
This is a model of a molecule. A molecule is two or more atoms that are bonded together. Each of these spheres represents an atom, and each of these sticks represents a chemical bond between the atoms. An atom is composed of protons and neutrons in the nucleus, and electrons which float around the nucleus. Now, the radius of the nucleus is tens of thousands of times smaller than the radius of the atom itself. That means that if this represented the size of the nucleus, then the size of the atom would actually extend out a couple hundred meters in each direction. And that's a lot of space.
These atoms are so small that in a single human cell, there may be about 100 trillion of them. In the entire body, there are roughly 10 billion atoms, meaning 10 followed by 27 zeros. Imagine how many atoms there are in a tree, or a lake, or in a mountain. Yet there is this large distance between atomic nuclei relative to their size. And the atomists saw evidence of this in how solid things like rock could be eroded, how plants grew, how life progressed from beginning to end. There is constant change and constant growth and decay, and they believed that it was the result of atoms and molecules breaking apart and coming together and allowing things to pass through the gaps between them. Their attempts to systematically describe the world and to make plain its complexity is called natural philosophy. The concepts of the atom and the void have existed for at least 2,500 years, and recently we have been able to see how these concepts play out on a universal scale, not just on Earth. So much of the universe is vacuum, meaning the density of matter is so low that it is close to empty. Recall that there are 100 trillion atoms in a human cell. In a volume of vacuum the size of an apartment, there might be fewer than 100 atoms. The vast spaces between planets, stars, and galaxies are vacuum. And this is just like the atomist idea of the void, where matter swirls and condenses and breaks apart. All matter that has ever existed is in this huge and mostly empty universe.
It is remarkable that the atomists and philosophers of old were able to predict and justify the existence of things that existed on scales so small that they could never be seen with the naked eye, and things so large that they exist on scales that we can never comprehend. They didn't have calculus or computer modeling, nor did they have telescopes or microscopes. They just had what was in front of them and their senses, and they reasoned their way to fantastic theories. It is that same human curiosity that they had that's led us to today, where we can ask big questions and find real answers.